Welcome back, guys. So this is question 2.22 and the statement of this question is the current I naught in the circuit in figure P2.22 is 1 amperes. Okay, so I naught, which is this current, this is how much? This is 1 ampere. So let me write it here. The value of I naught is 1 amperes. Okay, so on the basis of it we have to find I naught, which is here. Okay, we have to find the power dissipated in each resistor. Okay, we have to find the power dissipated in each resistor, and we have to keep it in our mind that the power dissipation formula in each of the resistor here is P of R is equal to IR square multiplied by the value of the resistor. Okay, so for that we will need what? We will need the value of the current which is flowing through each of the resistor here. Okay, so let me indicate the currents which we want to find and which we had to find out. So the first one here is I naught, which is already available. The other ones are this, let me call it I4 because it is going through or passing through this 4 ohm. Similarly, let me call it I10. Okay, this current which is flowing through this one, this is I25. Okay, and let me call the current which is flowing through this source, that is IG, or the current from this source. Okay, so these are the currents which we want to find out. And what other currents we want to find out? According to the part A, I want to find out I1. Okay, similarly here I4. Okay, similarly IG, which is here. Okay, similarly I10. These are the currents we want to find out, and this last one, that is I25, we want to find them out. Okay, so let us start and let me find them out. So first of all, we can see here that the voltage here, which is what? The voltage here is 150 volts if we consider this one as the ground, and on the ground we have here the 0 volt. So the voltage here is 150, and let me call here at this point the voltage equal to VB, and the voltage here is VA. Why this? Because I want to find out the currents, and I have told you that with each of the element here we have 3 quantities associated. Those are voltage, current, and the resistance. If any 2 of them are known, the third one can be easily found out. So if the voltages are known, we can easily find out the currents here. So first of all, we can see here that the voltage here is, let me call it V50, which has been dissipated across this 50 ohm resistor. So we can very clearly see that the value of V50 is 50 multiplied by I naught. The value of I naught is known, and that is 1 ampere. So therefore the value of V50 is 50 volts. Okay, so therefore if this voltage is 50 volts, from here we can very clearly see that this is the first voltage, this is the second voltage. So we can see here that 150, which is this voltage, minus this VB, that is equal to what? That is basically the V50. Okay, as the value of V50 is known, so therefore the value of VB would be equal to what? That would be 150 minus V50. So therefore this is 150 minus 50. So ultimately the answer of it is 100 volts. So the value of VB is 100 volts, which has been known. So this value is now known. Why this? Because this is the potential difference. If we have a resistor here and we want to find out, this is VB, this is VA, and if I want to find out the voltage across this resistor, this is what? This is, this VR is equal to VB minus VA, and that is what? That is the potential difference formula, and this is what I have applied here in this branch. Okay, so this is 100 volts and this is already known. So in order to find out the current here in this branch, and we can see that here this is VB and the voltage is known. So the current I25 is 100 volts, which is VB, divided by 25. So the value of it is 4 amperes. Okay, so this value is known, and that is 4 amperes. So let me write it here. This value is 4 amperes. This is known. Now here we can see that this is the current which is coming towards is, this is also the current which is coming toward this node as well. So therefore applying KCL here at VB, we can clearly see that I10 plus I0, that is equal to the I25, which are the currents coming towards the node, is equal to the currents coming away from the node. Okay, so here the I10 is unknown, while I0 is known, which is 1. Sorry, this is plus, and also the value of I25 is 4. So therefore on the basis of it, this I10 is 3 amperes. Okay, so I10 is 3 amperes. Let me write it here as well. Okay, so these two currents are known now. Now in order to find the I4, IG and I1, I must have this VA. Okay, in order to find the value of this VA, let me move down somehow. Okay, here. So in order to find the value of this one, I can very clearly see that here applying KCL at VA, we can see that I4 is equal to I1 plus I10. Okay, the value of I10 is what? This is the current which is moving in this direction. So that therefore this is VA minus VB divided by 10. Okay, so the value of I10 is known. The value of I4 is what? That is 150 minus VA divided by 4. Okay, so let me write them here. 150 minus VA divided by this resistance, which is 4. Potential difference divided by the resistance is equal to the current. Okay, so this is the formula I have applied here. Similarly for I1, I can see that this is VA divided by 65. Okay, so that is what? I1. So VA divided by 65, which is I1, and also the value of I10, which is already known, and that is 3. Okay, once this will be solved, we will get the value of VA equal to what? VA is equal to 130 volts. So this is what we can find out from here. When you will solve this equation, this is a linear equation, only one thing is unknown, and that is this VA. When you will solve it, you will get 130. So, okay, so as from this formula, we can clearly see that the value of I1 is here, and the value of I1 is equal to VA divided by 65. So the value of VA is 130 divided by 65. So we will get 2 amperes. So the value of I1 is 2 amperes. Okay, so the value of IA is known. Similarly, from this formula, which is this KCL, we can put the value of I1, we can put the value of I10. So the value of I10 is 3, the value of I1 is 2, so 2 plus 3 is 5. So therefore here this is 5 amperes. Okay, so these currents are known. Now the value of IG, we can see that this is IG, and here to this node this I1 is coming, and this I25 is coming towards this one. So therefore let me write it here. IG is equal to the I1 plus I25. Okay, let me put their values. The value of I1 is 2, the value of I25 is 4, so this is 6 ampere. So therefore this is 6 ampere. Okay, so we can see that all the currents are known, and we have all the currents, we have found them out. And now you can apply the formula which we have already seen here, and you can find it out. From this formula you can find out all the power dissipated in all the resistors. So let me first find out it across this 4 ohm resistor, and let me use this color. So across this 4 ohm resistor I will have P4 is equal to I4 square into 4. The value of I4 is 5, so 5 square multiplied by 4, so it would be 100 watt. Okay, so P4 is 100 watt. Similarly you can find it out for this one, for this one, for this one, for this one, and all the others one by using this formula. And at the end, when you will add them together, you will see that these would be equal to the power generated by this 150 volt source, and the power generated by this 150 is equal to what? That is Ig multiplied by 150. Okay, so Ig is already known, that is here. You have to put this value here, multiply them with 150, and when the power dissipated by all of these resistors will be added together, it will be equal to what? It will be equal to 6 multiplied by 150, and that is 900 watts. Okay, so that's it for today. The most crucial part here was finding all the currents which are here. Let me underline them. So these are all the currents which are the most crucial part we had to do here. So that's it for today. If you have any question, you can ask me in the comment box. See you soon.